Is this clear? Visible?
Yes, sir.
Okay. Now, see this example 3.7. The following table shows the distribution of the lifetime of 350 radio tubes. Right. Lifetime in hours, number of tubes. This is given. A radio tubes which have the lifetime of 300 to 400 hours, they are 6 tubes, right? Similarly, 400 to 580 and so on like this. Stating clearly the assumption involved, obtain the percentage of tube that have lifetime. First one is greater than 760, between 650 to 850 hours, less than 530 hours. Right? First one, greater than 360 hours. This is, sorry, 760. 760 lies between 700 to 800. Greater than this, that means greater than 760, some part in 62, then 22, then 4. Right? Got it? Now, over 760. This is 4 plus 22. This is not a 222. 4 plus 22 plus. Now, what we have done, that is greater than 760. That means greater than 760 is what? 40, because 700 to 800 they are ended as 100 as a part, right? So 100 hours, but we have to find only 40 hours, because more than 760 only 760 to 800 only 40% is there. So what we do 40% of 62, 40% of 62. So it comes to around 50.8, approximately 51. So 51 tubes having greater than 760 hours. But we have to find percentage, so we find the percentage. Total of all these are 350. So we find the percentage. Percentage comes to 14.57. Is it clear or not?
Yes, sir.
Clear?
Yes, sir. Clear.
Now, similarly, the second one. Second one is between 650 to 850. 650 here, 850 here, right? So that means 50% of this, 50% of this, and so that's it. 50% of 165, 50% of 22, and 62. 20. Is that clear?
Yes, sir.
We find this in the same way we can. Now come to the next one, cumulative frequency distribution. What is the cumulative? We have two types of frequency distribution, cumulative frequency distribution. One is a less than cumulative and other one is more than cumulative, two types, right? So what is that cumulative frequency? Come to this example. Marks given, number of students given, right? In this marks 30 to 35, 5, 35 to 40, 10, 40 to 45, 15, and all this, right? We have to find the less than cumulative. Less than, that means how many students got less than 30? Yes. How many students got less than 30?
Zero students.
Very good. 0. Right. And how many got less than 35?
5.
5. Very good. How many got less than 40?
15.
15. Is this clear? See, less than 30, because the mark starts from 30, 35, so less than 30 is 0. Then less than 35 is this complete, less than 35 is 5. Less than 40 is what? This 10 plus this 5. So it comes to be a 15. Similarly, less than 45, this 15 plus this 15. It comes to be a 30. Again, less than 50, this 30 plus this 30, 60. Less than 55, 60 plus this 5, 70, 65. Again, 65 plus 5, 70. This is the less than frequency distribution. Is this clear?
Yes, sir.
Now, in the similar way, more than marks. Fine. Okay. How many got more than 30?
70 students.
70. All students got more than 30. Right?
Yes, sir.
Now, how many got more than 35?
65 students.
Very good. That means we subtract 70 minus this 5. Similarly, more than 40. Again, we subtract 10 from that total. Then 15, then 30, and so on like this, right? So how many got more than 60? 0. Right? Is this clear?
Yes, sir.
Now, diagrams and graphs. Here, see this bar diagram. Line diagram is, see, in line diagram, we represent by line. See, in this example, the following data show the number of accidents sustained by the 350 drivers of a public utility company over the period of 5 years, right? So the number of accidents and number of drivers. Number of accidents is 0 to 11. That means 0 accident, there are 82 drivers who done nothing, right? Similarly, 44 drivers have 1 accident. 68, 2, 41, 3, and so on like this, right? Now, the first column should be x-axis and second one is y-axis. See, number of accidents we put in the x-axis and this one in the y-axis. We turn from the 0, 0, 1, 2, 3 up to 11. 0 accident, 82. 0 is here, 82 this. We just put a mark or make it this line dark. Similarly, 1 accident having 44 driver. So 1 accident having 44. Up to 44, we make one vertical line. Similarly, 2 accidents, 68. 268. We put 68 there and dark line this. We write the 68 because we got the exact figure. And similar way we turn on. Is this clear? Now comes to the
Yes.
bar diagram. Bar diagram is like a simple diagram, subdivided, percentage, multiple, or division. Simple bar diagram. Look at this example. The following data relating to the strength of the Indian merchant shipping fleet gives the gross registered tonnage as on the 31st December for different years. Year is given, jet is given, right? So first column like this year, we put in the x-axis. This is called the x-axis, fine. And this vertical line is called the y-axis. That is always the second thing. Now, in this 1, 2, 3, 4, 5, 5 different years are given. 1961, then 66, then 71, then 75, then 76. Right? Now, GRT is 100 given, in hundreds given. We write in the y-axis 1500, 3000, 45, and so on. Right? Because these figures we cannot write exactly, we can write because this is a 901, 1792. So this is very difficult to draw on this graph paper. Right? So we should rewrite this. Now, this is called a kink. This show, this line, this is called a kink, this zigzag line. This show that because what happened? The year is given 1961. Prior to this, 1960 or 1959. But we have started from 1961. So we make this kink line. It shows that this one is a continue and we have started from this. Right? Now, what we do, this is 1961 and 1966, 5-year gap. So accordingly, we make a 5-year gap. Fine. Then 66 to 71, again 5-year gap. So we again make the same distance. Then 71 to 75, that is a 4-year gap. So we make this distance left. That is according to 4 years. Then again, 75 to 76, there is 1-year gap. So we make a very little space between them. Is that clear? So accordingly, we make this diagram. The first one is what? 901. So tentatively we write 901 and we write the 901 over this diagram. So that means this rectangle represents 901 figure. Similarly, the 1966 triangle represent 1792 and so on like this. Right? So this is the bar diagram, simple bar diagram. In the bar diagram, we represent by this rectangular type of figure, right? And in the diagram, we cannot join these one. We cannot join these rectangular points. Fine? No. Subdivided or component bar diagram. This is subdivided. Right? Wait. Yes. Now, this one. This is subdivided. What we do, we subdivide the single bar diagram into this. Now, sorry. In this, given family A and family B, income of family A is 500, income of family B is 300, right? Fooding given, sorry, the expenditure on food, clothing, education, miscellaneous, saving, and deficits, all are given, right? So that data can be in the subdivided. See what we do. This is a 3 and 500 income and 300 income. What we do, this is 500. Similarly, this is 300 like this, right? So first of all, saving 10, saving 10. If we total these things, it got 500, right? Now we start from this. This is 10 saving, right? Then 10 plus 190 become 200. So in 200, we make a line. This line and this line. So this is comes to be a miscellaneous automatically, right? Then 200 plus 25, 225. So we make line on 225, 225 a line. This comes to be a education, right? Then 225 plus 125. This is 225 plus 125. That is 350. 350, we make a 3 line at 350. This is clothing. And rest pair is food. Similarly, this deficit is 30. So this comes below this, right? Deficit 30. Then 70. So at 70, we make a line, right? Because from 0, it is 70, right? Total is 300. Now 300 is what? This comes to be a total 300. So minus 30 getting, so minus 30, sorry, 70 minus 30, 40. We make a line on at 40. Then again 40 plus 50, 90. We make a line at 90. And so on like this. Right? We make a different color, similar in miscellaneous. This cross line, similarly here cross line. Plain for education, plain clothing for this type of design. We make a dot on the food, but this represent this fooding, clothing, education, and so on. Is it clear? Is it clear?
Yes, sir.
Percentage bar diagram. In percentage, we make a percentage of these. For example, this expenditure all are given, right? We make a percentage. So we calculate the percentage of each and everything. So how to do the percentage? Make a total of this. Total comes to be at 720, right? So we make a percentage of this. 240 divided by 720 into 100 comes to a percentage, right? This is a cumulative percentage. That means the similar way what we have done the earlier. 33.33. Then for the cumulative, add 9.17. Then in 42.7, add 17.36. Then 59.86, add 7.92, and so on. At last, we got 100. That is total 100%, right? So, see, this first one is 33.33. In 33, this is a x-axis, y-axis up to 100 because this is a percentage. So we divide into the percentage gap of 10 or 20, whatever. 10 is a good thing. So 10, 20, 30, 40, 50, 60, 70 up to 100, right? So we make a rectangle of 100. That's it, 100. Because we know that this is up to 100. Now the first one is 33.33. So at approximately this 33, we make a line. This is a food. We make a tag. They have tagged this portion. So that means this is a food. Now come to the second one, that is clothing. Clothing is come to the 42.5, right? So in this 42.5, 42 is above this 40, right? We make a straight line. This is for the clothing, right? So we make this type of dash. Again, the next one is rent 59.86, 59.86. We make this and we make these cross line lines, right? Again, fuel and lighting 67.78. We make straight line at 67.78, approximately 68. This is fuel and lighting. Again, the next one is education, that is 73.61. At 73.61, we make a line, we color this type, and the rest one is the miscellaneous. Is it clear? Clear?
Yes, sir.
Multiple part diagram. The data below in the yearly profit, 1,000 of rupees of the two companies A and B. 94 to 95, 95 to 96, and so on for the company and company B, right? So in the x-axis, we write this year, 94 to 95, 95 to 96, and so on. At the y-axis, this is what up to the maximum one is 175, 175, yes. So we make up to 175 or 200, right? Now, for the first one, company A, 120, we make a bar diagram of 120, right? In the similar way, the company B has the 90, so we make a 90 here at joining this. So this cross line shows the company B, and this shows the company A. We already marked here. This is the company A, the company B. In the similar way, the 95 to 96, 135, we make a bar diagram, and at joining this of the 95, and so on. Right? So this is a multiple bar diagram. Is it clear?
Yes, sir.
Division bars. In division bars, we make a diagram of differences, right? For example, this. For the following data, prepare the suitable diagram for showing the balance of trade, right? For the balance of trade, we either need profit or deficits. So in this given export and import, right? Export and import, for the balance of trade, we make difference of this, right? Because if export is more than import, then it is good because we are selling more things than purchasing, right? So in positive, this is good. But if it is in negative, that is not good because we are importing more things, right? So we make a similarly x-axis, y-axis. Above the x-axis is positive, below the y-axis is, x-axis is negative, right? 94, this is positive 15, balance of trade. 1994, 15 above this. Similarly, 23 above this for the 95. 96, that is minus 8 below this, then below this, then below this, then below this. That's it. Right. Broken bars, what happens? See, in this data, right? All these are given. But you have seen, we can draw the graph of this, but for the USA, the figure is much more higher than the others. If we compare with the others, see, for the Burma 53, Czechoslovakia, this is 522, and so on like this, right? So, but for the USA, the figure is much more than the 53 and 12,699. That is much more than these figures. Generally, they have 2,000, 3,000, but 12,699 is much more. So we cannot represent for the single one in this. So what we do, we make this bar diagram and we show it by the broken bars because we represent up to 600, but this one is very much. So what we do, we just break this bar and show that this is 1260. That's it. Simply, this is called a broken bar. Right. This pie diagram is important. See this pie diagram. In this example, draw the pie diagram. They've simply written that draw the pie diagram, right? Draw the pie diagram to represent the following data of proposed expenditure by the state government for the year 1997 to 98. Items are given. Items are like agriculture and rural development, industry and urban development, health and education, and miscellaneous. Proposed expenditure in millions. Right? What we do, make a total of this. Total comes to be a 7,200, right? So we need the percentage of all this, right? The percentage 4,200 divided by 7,200 into 360. We also find the percentage, but this is the angle because pie diagram is what? This is a diagrammatical representation in a circle, right? So in a circle, the complete angle is a 360-degree, right? So what we do, we make an angle of this. So 4,200 divided by 7,200 into 360, right? It comes to be a 210. In the similar way, 1,500 divided by 7,200 into 360, 75 and so on. Right? Now, see, we make a circle, right? We make a circle, one straight line, one radius anywhere. X-axis is better. This will make a horizontal line, right? So, with the help of protractor, we make 210-degree. 210-degree. We make another line. So now this complete angle is a 210. This is a agriculture and rural development. Again, we put protector here. We make a second, that is 75 angle. We make a 75 angle. We put other line. This is industry and urban development. Again, protector here. Make a line. This is a health and education. And the rest one is a miscellaneous. That's it. This is a pie diagram. Now come to this graph presentation. Now, graphs of frequency distribution. Now, come to this graph. See, diagram is different from graph, right? Now see this graph. In this is graph for x-axis, that is a horizontal line, and the vertical line is y-axis. We called right side is a positive x-axis, left side negative x-axis. Similarly, above this positive y-axis and below this negative y-axis. Right? Wait, my earplug is not working. Wait. Do you hear me?
Yes, sir.
See this, right? So above this positive y-axis, below this negative y-axis, right? X is positive, y is positive. Here it is x positive, y positive. Both are positive, right? Similarly, here x is negative, y is positive. In this, x is negative, y is negative. Here, x is positive, y is negative, right? This is called the first quadrant, second quadrant, third quadrant, and fourth quadrant. Quarter, 1/4, right? So we divide these graphs into the 4 parts, right? For example, point is 4,2. So 4 is x-axis and 2 is y-axis. Here 2, here 4. Point comes to be here. Clear? Similarly, the point is -3, 4. So here x is -3 and y is 4. First, always represent the x-axis, and the second one is y-axis. So x is -3, y is 4, y is 4. So -3, if we could straight line this, -3 and 4 here. So we make a point. Circle it. This is a point -3, -4. -2, -3. X is -2, x is -2, y is -3. Similarly, 3, -2, 3 is positive x-axis. Second, y is -2, -2. Graphs of the frequency distribution. We further divide the graph into this histogram, frequency polygons, frequency curve, Ogive curve, and so on. Come to be the histogram. Draw the histogram for the following frequency distribution. Variable is given, the frequency is given, right? The variable is 10 to 20, 20 to 30, 30 to 40, and so on. Frequencies, corresponding frequencies are given. We have to represent this in the histogram, right? See, the variable. Variable always lies on the x-axis, right? And the frequency in the y-axis. Look at this graph. X-axis, y-axis, right? Now, variable in the x-axis, see the variable. variable is starts from 10 to 20 up to 70 to 80. We start from this 0, 10, 20, 30, 40, 50, 60 up to 80. Additional we make a 90. And the frequency is up to 65 is the maximum one. So we make a difference of 5 or 10, whatever. So 10, 12, and up to 70, that right? The first one variable is 10 to 20, the frequency is 12. 10 to 20, frequency is 12, right? So we make a rectangle like this. Again, 20 to 30 is 30. Adjoining this, 20 to 30 is 30. We make a 30 line and we make a histogram. In the histogram, all the rectangular are closely packed, right? But in that one, the distribution bar diagrams, all the rectangles are separate, right? In that, all the rectangles are separate, but in this, we make a adjoining connecting to this one, right? In the similar way, the next one, 30 to 40 is 35, 35 again, we make a this, and so on. This is called a histogram. Is that clear, beta?
Yes, sir.
In this, we have started from 0 to 10. If it is started from 30 to 40 like this, we again make a kink line here, right? Like a this zigzag kink line here. Well, similarly, right? See, in this example, what we see, 10 to 15, 15 to 20, that is 5 gap, 20 to 25, 5 gap, 25, 35 gap. But in 30 to 40, there is 10 gap, 40 to 60, 20 gap, 60 to 80, 20 gap, right? So what we do in this case, see, because we make a similar difference, to make a similar, what we do, 10 to 15, this is the same. Now come to this 30 to 40, right? So in 30 to 40, there difference of 10, but we need the difference of 5. If we further subdivide this 30 to 40 into two parts, 30 to 35 and 35 to 40, 30 to 35 and 35 to 40, right? So we divide into two parts. So further what we do, we divide this 12 into 2. Divide 12 by 2, that is 6 parts each, right? Similarly, 50 to 60, difference of 20. In this classes, difference is 20. So with the divide by 5, all this becomes, because we further divide into how many parts? 4 parts, sorry. 40 to 45, 45 to 50, 50 to 55, and 55 to 60. We divided this into the 4 parts. So what we do, divide 12 by 4, comes with 3. In the similar way, 60 to 80 divided by 4 comes with 2. See what happened this. We make difference of 10, 5. 10 to 15, 15 to 20, 20 to 25, 25 to 30. Further 30 to 35, 35 to 40. Then again 45 to 50, 40 to 45, 45 to 50, 50 to 55, then 60 again, so on like this, right? So see, 10 to 15, 7, 10 to 15, 7, then 19, then 27, then 15. This is up to this fine. Now come to 30 to 40. See, in given question, the interval is 30 to 40, but we have adjusted into 5, group of 5. So what we do, because we don't need 35 here, so no need to write. If you can write, it's no issue for that, but don't put the line over here. 30 to 40 direct, 30 to 40 direct, and we make a 30 to 40 of interval of 6, right? This means 30 to 35 is 6, 35 to 40 is also 6. it becomes 12. Got it?
Yes, sir.
In the similar way, 40 to 60, we divide into the 4 further parts. So 40 to 60, right? No need to write 45 or 55 or 50. Further, the adjacent interval is what? 3. So it should be 3. That means 40 to 45, 3, 45 to 53, 50 to 55, 3, 55 to 63. All are 3. 3 plus 3, this is 12. So this becomes 12. Again, 60 to 80, 2. 60 to 80, 2 for the in the similar way. Got it? Is it clear?
Yes, sir.
Now comes to the frequency polygon. See what is the frequency polygon. In this example, in histogram, frequency polygon is what? We do the draw the histogram, right? And make the midpoint, mark the midpoint of here. Here also in 10 to 20, midpoint here, 20 to 30, 30 to 40, then 40 to 50, so on. With the help of scale, this midpoint, draw the straight line. Similarly, 30 to the midpoint of this one, midpoint of this one. With the help of scale, straight line this. 30, midpoint of this one and this one. Make a straight line. Similarly, straight line, and so on. So this comes to like this. This type. Is that clear?
Yes, sir.
Fine. Now, the next one is frequency curve. Frequency curve. If this polygon, if you draw these point with the free hand, don't use the scale. If you do with a free hand, that is called a frequency curve, like this. Frequency curve. Clear? Clear?
Yes, sir.
Only you are responding, not Divya and Nancy.
Yes, sir.
Nancy in the sleepy mode?
No, sir.
Okay. Now, the last one is frequency curve. That is for the more than and less than. This cumulative frequency curve, that is called a ogive curve, right? So we have done the two types of frequency distribution, less than and more than, right? The similar way, they are the two type of the ogive curve of the similar distribution, right? But we have made the less than and more than frequency curve. See, the example is given, right? Okay, look at this. Is given. So we do less than and more than. That there difference of 75 in the each cases, right? So in the similar way, less than 60, and we make a less than CF, less than CF, less than 75, less than 150, and so on. Similarly, more than 75, and we make a CF, right? So x-axis is the monthly income and the number of family in the y-axis, right? Now, here in this all having the difference of 75, so we assume that there is the lower limit of first class is 0 to 75, right? In the similar way, this is 450 and over. So what we do more than 450 add 75, that is, it comes to be the 525. We assume that the more than is the upper limit is 425, right? So see, the less than 75, or we say less than 0 is 0. So we start from this 0. First point is 0, right? Second, less than 75. Less than 75 is how many family? 60. Less than 75, at the 75, we make a 61 point. Right? Less than 150. How many? 230. 150. 1 point make 230. Then 430. Next point, that is at 225. This point. Again, this point, this point. By the free hand, we join all these points. This is called a less than ogive curve. Less than ogive curve. Right? In the similar way, more than 0 is total. Total is 600. So 0 at this point, 0, 600. We make 1 point here. More than 75, 540. At 75, 540, we make this point. Similarly, more than 150, 370. At 150, 370, we make at this point. And so on. All join these points. These are called, this type of graph is called more than ogive curve. More than ogive curve. Is that clear?
Yes, sir.
Yes, sir.
The intersection of these two curves, less than ogive and the more than ogive, that is a median. That is a median. We do further in further classes what is a median and all, right? So this is median. Is that clear?
Yes, sir.
This part is finished. Curve graphs is. From the next we start the practical part. That is the most important part in the next class. That is a central division, measure of central division. That is the most important part. That is a root of stats. Right? So be prepared for the next class and tell everyone to attend that class. That is the important class for all.
Okay, sir.
Right? So I wind up here.